Well, in the last session we discussed about Korn shell interactive session. So here we discussed about what are the K shell features, what are input and output statements, environment variables and different options. Okay. In this session we'll start new chapter, that is shell programming, K shell programming. Okay, so here program is nothing but it contains some set of instructions or commands. Okay, so here this shell script is a file that contains executable commands. Okay, so we can execute these commands at the shell prompt as well. Okay, so virtually we can execute these commands, but what is the need of writing this one? Suppose if there is any long script or long command, okay, or if you're executing some commands, some set of commands frequently, then you can write a small file or a script file, and you can run this particular script, and all the commands specified in the file will be executed in the specified order. Okay, sorry. So here this script file contains some set of commands, executable commands. Okay, so next one, this script file generally contains three components. Okay, so we'll see what are those components. Generally any script file generally contains three components. So one is interpreter designator, next one, so this one is optional, comments, but it is always best practice to write comments or documentation part of the script program or file. Okay, so comments and shell commands, so minimum one or more shell commands. So any script file generally contains these three components. Interpreter designator, it is must. Okay, so if you, this is also optional, but it is always best practice to write interpreter designator. What is the use by writing this one, and what if we don't write this line? Okay, so that we'll see. Next one, components, sorry, comments. Okay, so it is always best practice to write comments about your script file or about your program. What is this program, who is the author, when it is created, okay, what are the modifications done on this file, so everything. So generally your comment is nothing but first line, first character in the line should be hash. If the line starts with this symbol, okay, if the line starts with this pound symbol or hash symbol, then that line is comment. So this line cannot be interpreted by your interpreter or cannot be executed by your Unix. Okay, so that line is only commented line. So it is only readable purpose, it is only for better understanding about the script, or it is only to know more about your script. Okay, so whatever is documented, so that is for better understanding for the other users. Okay, fine. So here generally your script contains these three components. So next, third one is shell commands. Okay, a shell command means any Unix command. Here it allows any Unix command. Okay, so this command or this statement can be any Unix statement. Okay, so it can be command or conditional statement or looping statement, whatever it may be. So any Unix command is supported here. So your script contains only these three components. Out of three, first one is optional, second one is also optional, but if you are writing some program or script, it contains at least one command. Okay, minimum one command. So without command there is no need of writing script file or program. Okay, fine. So but it is always best or right procedure or best practice to use interpreter designator, line and comments. Okay, we'll see what is this interpreter designator. Interpreter designator, fine. This interpreter designator should be the first line of the script file. It should be the first line of the script file. This line tells Unix the path to the appropriate shell interpreter. Okay, your shell, I mean Unix shell, will have some interpreter. Why do we require interpreter? The reason is the Unix commands or statements are in the form of English words. Okay, so these should be converted or these should be interpreted, okay, to the machine understandable format. That's why we require interpreter. So Unix is having some interpreter. Okay, so this particular first line, that is interpreter designator, will tell the exact path for this interpreter. Okay, so we need to give this particular path. Okay, how to find this path and what is the line appearance, that we'll see. So this interpreter designator line should start with a pound sign and bang symbol, exclamatory mark. Okay, so after this you can specify your interpreter path. How do we know this path? How can I come to know my shell is having this particular path? Okay, so my K shell path is so and so. That you can check with a command. Fine. So generally this path can be, okay, so depends on the system configuration. Again, there is a command that you can check. So this interpreter path, Unix path, can be bin/ksh, or it can be a user, okay, /bin/ksh. Okay, so here your K shell interpreter will be recognized. Okay, so it will give you the path. So here you are specifying the path. So after this line, whatever the Unix command you specify, that will be executed. Okay, so either of this one generally. So how to check this one? You can check by using which KSH. Okay, if you are writing K shell script, which KSH. If you are writing some B shell script, bash, which bash. Okay, so this is B shell scripting. Okay, now we are writing K shell scripts. So which KSH? It will give you the path. So in this particular system, this is the interpreted path. Okay, so your script file first line without any spaces. The rule is without any spaces means when you open the file, first line, first column should be hash or pound symbol, next bang symbol. Okay, so after these two characters you need to specify the interpreted path. Okay, so as per my system, the path is usr user/bin/ksh. Okay, so this should be the first line in the program. Okay, so after this you can use comments if you want. See, I am writing some comment. You might be asking, like, here hash is preceded, or this is the first letter in the line, but this is not comment. When hash bang symbol is there, and that too, this should be the first line. This should be the first line. There should not be any empty lines. There should not be any column spaces. Okay, so this should be the first line and first column characters. Then you specify the path. So this is interpreter designator. Next, you can write, I mean, you can use your commands, or you can comment about this particular script and then start writing commands as you wish. These two are optional. Okay, so commands is compulsory but comments is optional. Here I am writing one comment like so this script is to display date and cal. Okay, some comments. Okay, or I can also write like one more comment. See, if you are writing comments, only the line first letter or line should start with pound symbol. Okay, so then if you want to write more than one line as comment, then start that particular new line with pound symbol. Okay, fine. Some other name, date of creation of the script, and so on. You can write some details about the script, who is what are the modifications done, who done these modifications and all. You can write all the documentation part. So now you can write commands whatever you want. Based on the requirement you can write commands. Okay, so here I am using two commands. One is date, another one is cal. Okay, so just we are executing two commands. Okay, one is date, another one is cal. So this is the script. Okay, fine. We'll try to create this file. Okay, so before going to create this file, I would like to show you what if we miss this particular first line, interpreter designator. Okay, what happens and how do we execute this script file without designator. Okay, fine. See, here I'm going to write one sample file, sample script. We'll create all our scripts in a new directory. I'm creating one directory. We are changing into this directory. Now we are in this directory. I am going to create one file, script file. Okay, so this script file name is one. So this is the script name. To identify this script is KShell script. I am using one extension, that is KSH. Okay, so this is not compulsory. Okay, for next scripts we will use this extension. For this we are avoiding this one. Okay, example 1, examp1. Okay, now press enter. Here I am writing a small script to display date and calendar. Okay, now my first line. Okay, I am writing one command date, another one is cal. Okay, I am going to save this file, this script file. The script file name is examp1. Okay, so the script is, one program is created. Now we need to run this program. Okay, so how to run the program? It is very easy to run the script file. Just give the script file name examp1 and press enter. Okay, now if you press enter, it will display one error, command not found. The reason is, actually it is a script file. We are assuming it as a script file. It contains two commands. Okay, but it cannot be, Unix cannot able to recognize what is the interpreter. Okay, so it cannot able to identify what is this particular thing exactly. Okay, as a owner of this file, you know that this file contains two commands. One is date, another one is cal. These two are Unix commands. Okay, you know this one, but we should tell the same thing to the Unix, that it is a script file. It is a KShell file, KShell or KShell script file. Run this file. Okay, now so the command is exactly same, the file name and press enter, it will be executed, but it cannot identify this one. One way is KSH. Now we are telling that K shell, open one K shell and run this particular script in the K shell. Okay, so KSH means already we have seen in the last sections, we have seen examples. Okay, how to open a shell, subshell, and so on. Okay, so we are telling KSH examp1. Okay, now we are telling to this Unix that K shell, open one shell and run this file there. Now it will assume it as a script file, and whatever the commands given in this file, those commands will be executed. Okay, so because of this one it is executed. Now see, I am going to change this file in such a way that see, this is first line, no column spaces, no line spaces. Okay, I am adding this first line. Okay, so pound symbol, exclamatory mark. After this you need to specify the path. As per my system, user usr slash bin slash ksh. This is the path in my system. You can check this path by using which ksh. Okay, it will display the path. The same path you can use in your file. Okay, fine. I am going to save this and close this one. Okay, what is my file name? Script file name examp1. Now press enter, see the effect. So in the previous, without that first line, if you execute, here we executed, we got some error, right? Now I am executing this file. Oh. Okay, for this we need to change to, okay, we are here, present working directory is this one. Okay, examp1 and press enter. Here also command not found. Read, write, right. Here we don't have execute permission. Here we don't have execute permission. So if at all you want to run any file, it should have executable permission. Okay, so I am changing this permission, change mode 755. Okay, 7 means as a owner of this file, I'll be having all read, write, execute. Others and group will have read and what you call execute. Read and execute, not write permission. 5 means read and execute. Okay, file name examp1. Okay, fine. Now run this file. If you want, you can check what is the permission. Yes, here we have X means executable permission. Even group and others also have executable permission, so they can also run. Now examp1 and press enter. No such file or directory. amp1. Yes, examp1. Hash bang symbol. No. Okay, we must use PMP. You can run just by giving file name. Here it is not executing. When your first, when in your script, if the first line is designated, then definitely it should work. Only file name and press enter. Okay, only file name and press enter. Your script file will be executed. Okay, otherwise, let me try one more. Like I'll give some extension to this file. MB examp1 to examp1.ksh. Okay, fine. Let me check. Yes, examp1.ksh is not found. Right. So here it is not taking, but one way is just if the path is a first line designated line is used in your script, then only script name and press enter, that script will be executed. Okay, so that is one way. Another way of executing the script is ksh, means we are telling to the computer Unix that execute this particular file in a K shell. Okay, so ksh space examp1.ksh. Okay, your script file name and press enter, that script will be executed. Okay, so this is the way of executing the script. So create a file, script file or program, and after completing the program you can execute this particular program by specifying the script name or program name and press enter, otherwise ksh space program name. If your script is taking some parameters, then you can pass those parameters while executing the script. Okay, if it is taking some parameters, use those parameters. Okay, fine. Like suppose we'll modify the same command like vi examp1.ksh. Here just I'll pass one more parameter to this one, and using print statement I am going to display that value. Okay, so I'll pass only one parameter. So $1 means first parameter, it will take the first parameter. We have separate topic, there we will discuss about parameters, how to pass parameters. So vi examp1.ksh. So this script requires one parameter, so I am passing that parameter hello. Okay, now press enter. Oh, I said VI. So instead of KSH, I said like, okay, fine. Run this one examp1.ksh space that parameter. Okay. Now press enter. This script will be executed. It contains three commands. First one is date, calendar, and next one is we are printing the first parameter. So this is the parameter. Okay, so this first parameter will be referred or accessed with $sign and parameter number. Okay, so like this you can pass some parameters. So second one will be $2, third one will be $3, like this. Okay, so just we are printing this parameter value. Whatever the parameter passed to this script, that just using print statement we are printing that value. Simple. Okay, so this is one small script to display date, calendar, and parameter value. Okay, fine. So there are two ways to execute the script. First way is in your script, if the first file is your designator, interpreter designator, then script name and press enter. If parameters are there, pass the parameters. So this is one way. Second way is ksh space script name space list of parameters if required. Okay, so ksh space script name and press enter. You can pass if any parameters are required. Okay, simple. Fine. So this is the script file. Okay, now see how do we write commands. Okay, here we are using commands. Okay, so all these three commands we specified in new line. Suppose if you are writing commands in one line, multiple commands in one line, how to write? Okay, so as discussed in the earlier sessions, here you are writing in a separate line. So here these three commands, see print $1. Okay, so here this script contains three commands, and every command is separated by new line character, right? After date we press enter key, means new line character is there. So after cal, new line character. Okay, after print it may or may not contain new line character, so there is no need of new line. Why? Because this is the last command in the script. Okay, fine. If you are writing in a single line, then separate every command with semicolon. Okay, it should end with, every command should end with semicolon. Okay, so this is must if you are writing more than one command in one line. Okay, next one, making scripts executable. How to execute a script? If it is having executable permission. Okay, if the script is having executable permission, then we can run the script, right? See this file. Here user is having executable permission. That's the reason we are able to run this script. Otherwise we can't run the script. Okay, so this is read permission, write permission, and X is the executable permission. Okay, so that is the reason we are able to run this script. Okay, so if you want to run the script, the script must be having the executable permission. Okay, so next one is parameters, assigning and positioning the parameters. Okay, how do we pass parameters to a script? Okay, it is very simple. Whatever the parameters script required, those parameters can be passed at the time of executing the script. Okay, like see this example. So this is my script examp1.ksh space. It requires some parameters like so this script requires some parameters, so I can pass those parameters while calling or while executing the script. So your script name space, so this is the first parameter space, second parameter space, third parameter space, fourth, fifth and sixth. Okay, how to access or how to refer these parameter values? Anyway, we are passing parameters, some parameters to the script. How the script can be accessed? These parameter values. Okay, so that we'll see. See this. I am opening the script. So a parameter can be accessed in the script by using $sign and that particular parameter value. Okay, see this example carefully. Now here I am going to just print the values which are passed to this script. Okay, see I am going to print in the reverse order. Like first I am going to print the last parameter, that is seventh one. Okay, now print $6. Okay, just I am printing whatever the parameters passed to this script. I am going to just print those values. Okay, now this is my script. This is my script. I am printing these values, right? Now run this script. So this is $1. This parameter is $1. This is $2, $3. Okay. So in this way we can access in the script, right? So this one is $4, 5, 6, and one more Saturday. Okay. Now if you run this one in my script, I am printing just parameter values, but in the 7th parameter to 1st parameter. Now see this output. I got Saturday, Friday, Thursday. So 7th parameter first. Why? Because in my script I am printing $7 first, then $6, $5, $4, $3, $2, and 1. Right? So this is the parameter passing and accessing the parameters. This is the parameter passing and accessing the parameter values. Okay. So in the coming sessions, when we are writing some programs or script programming, there we require some parameters. Based on the parameter value, we are going to do some process. Okay. So based on this parameter value, we might take decisions or we might do some process. Okay, when this particular parameter is passed, then do this one, otherwise do this one. So in this way there might be some decisions or there might be process, depends on these parameters. Okay, so that's the reason parameters concept is important, and generally we use this while writing scripting. So next one is expressions. Okay, this topic is almost similar to the topic which we discussed in the awk command. Next one is expressions. What is an expression? An expression can be either, like, suppose if you take some programming language, we have expressions. Even in general also, in mathematics also we have expressions. Okay, so here we have different kinds of expressions. So those expressions can be some mathematical expressions, relational expressions. Okay, so or some logical expressions or file expressions. Okay, so how these expressions can be built or made? See this example, c equals to a plus b. Here this a plus b is one expression. This expression is made up of with operators and operands. Operators and operands. Here what are operands and operators? A and B, these two are operands, plus is the sign which is operator. So expressions can be built or made up of using operators and operands. In Unix operating system or causal programming, we have mathematical expressions, relational, file, and logical. These are the different kinds of expressions we have. Mathematical, relational expressions, file expressions, and logical expressions. Okay. Okay, so these are the four kinds. First one will take mathematical expression. How do we write mathematical expression? Mathematical expressions can be built by using mathematical operators. Okay. Anyway, operands are required, but basically these can be built by using operators. Okay. So we have mathematical operations like addition, subtraction, multiplication, division, and finding the modulus. Okay, for all these operations we have some operators. For addition, use plus sign. For subtraction, minus. For multiplication, use this asterisk or asterisk symbol. Next, for division, slash, and modulus, percentile symbol. Okay, so these are the mathematical operators which are used to build mathematical expressions. Okay, almost we discussed it in the earlier sessions. Okay, now we'll see some examples on this. We'll try to see some examples on this. See here, I am going to write one small program. That program is sum of two numbers. Okay, I am going to sum two numbers. .ksh. So in every script, the first line should be, it should be the interpreter. Okay, line. So first line without any spaces, column spaces or row spaces. Okay, hash pound, next path, user bin ksh. Now documentation, it's your wish, you can write. I'm writing like this script will add two numbers 34 and 66. Okay, fine. Next, I am taking a variable and storing the value 34 in this. You can also read from the keyboard as well if you want. Okay, and b equals to, I am storing 66 in this, and now I am writing one statement like c equals to, okay, c equals to a plus b, okay. You know that Unix operating system will treat everything as a string, right? So here we did not use any typeset to convert into integer, or we did not use it as a and b as integers, right, or c as integers. Okay, fine, remember that. And we are going to display this c variable value. The result is, how to display variable value? Precede variable value with $sign. Okay, this is my program, some small script to add two numbers a and b values. I am taking a value 34, b value 66. Now you can have some spaces. Okay, only the condition is here I am using one empty line. Okay, so this is allowed. Anywhere you can use empty line, no problem, but you should not use your first line. It should not be empty, or there should not be any column spaces or row spaces. Okay, it should be the rule. So later you might be having any number of spaces, no issue. Okay, now save this and close this. Run this program, ksh sum2.ksh. See the result. Here result is I am getting some expression a plus b. Here a value is not added, b value is not added, right? So here this c, okay, if you again go back to program and see here c equals to a plus b. It is assuming this a plus b as a string, not as a expression, not as an expression. Okay, it is assuming it as some string. Okay, so now our task is, we should tell explicitly these two are integer values, or do some mathematical calculation on these. Okay, how do we do that, or how can we tell that? Okay, yes, we have two expressions. One is either you can use expr command or let command. Okay, so by using these two you can tell that these two are integer values and add these. Okay, just I'll write in one line. Okay, see here you can use expr or let. Okay, so this let, I am saying that expr command or let command. Okay, let space some c equals to 88 plus 12. Okay, what is 88 plus 12? 90, 100. Okay, 100. So we should get output 100, 100. Okay, let us check. Now run this script. See, the result is 100. The result is 100. Okay, so we are getting. Okay, fine. Another way is, here you can use let command or expr. So this is expression. So this is the one of the old command. Okay, so which is generally used in the bourne shell. So in K shell you can use the latest one, let command. Okay, or you can also use expr, no problem. Let, fine. So before this I am declaring some variables. 32, b equals to 77. Now I am using let command, and using this I am going to add these two numbers a plus b. Now run this. Here you should get sum of these two numbers, 109 we are getting. So here let command will convert a value. It will take a value as integer, b value as integer. These two will be added. Some mathematical operation will be performed on this expression, and you will get the result into the C variable. And next statement you are going to print that result. Okay. So this is another way of writing by using variables. And next way is, let me comment this. Sorry. Just I am commenting this one. So these lines will not be interpreted and will not be executed. Okay, fine. Now here I am writing one more way, like a equals to some 12, c equals to, okay, no sorry. You can also write your expression in between double open parentheses. First let me write down the expression. C equals to a plus some 34. Okay, so here I am using one constant value 34, a variable value. I am doing mathematical operation between these two and storing the result in C. I am placing this entire expression between open and close pair parentheses, double parentheses. Okay, now this whatever is placed between double open parenthesis and closed parenthesis, that will be a expression. It will consider it as a expression. Okay, now execute this one and see the result. Okay, sorry. So here 12 plus 34, you should get 46 as output. Now run this one. Yes, we are getting 46. So these are different ways to write a mathematical expression. Okay, so if you don't use any one of like let command or expression command or parenthesis, double parenthesis, okay, it should not be single, it should be double. Okay, double open parenthesis, no spaces between these two. After this you can give some space, no problem. You can write statement like this, no problem. So next to close parenthesis, double. So here no space is allowed. Okay, now it will assume or it will treat it as an expression and it will do some calculation on this data. Okay, otherwise it will assume it as a string and it will concatenate. Suppose if you say C equals to 22 plus 32, just it will display 22 plus 32 as a string only. Okay, so to do mathematical operations there are three ways. One is you can use expr, expression command, or let command, okay, let let command, or use open parenthesis, double open parenthesis and double close parenthesis. If you write any statement between these two symbols, that will be a expression and it will do some mathematical operation on that data. Okay, right. So this is about mathematical operations. Like this you can use some more operations, like we have mathematical operations, subtraction, multiplication, division and modulus, right? So you can do any operation. Okay, so this is arithmetic operations or operators. Next we have relational. Okay, so we know what are relational operations, we discussed in the awk utility. Okay, so the relational operations are comparing two elements, whether the first element is greater than second element, less than second element, greater than or equals to, less than or equals to, not equals to. So these are all relational operations. Okay, so we'll see what are relational operators in this K-shell scripting or programming. Okay, so this is greater than. Okay, so we'll see what are available. Greater than or equals to, no space between these two symbols. Again, less than or equals to, equals to and not equals to. Okay, see, you can compare two elements are equal to or not equals to or not if both are integer values. Okay, suppose if you are comparing some string elements, like two strings are equal to or not equals to or not. Okay, then in that case you can use for string operations, I am saying, not for integer. For integer you can use this symbol. For string operation, suppose a is a variable, string variable, it contains hi. Okay, now b is another variable, it contains some hello. You want to compare these two, then you can use a equals to b. Now it will check a string is exactly equals to b string or not. If it is not equals to, it will return some non-zero value, it will return false. Okay, so here in this case it is false. Suppose if b contains hi, then this result, this expression is true. Okay, so for this string comparison, for equality of equality operation, use equal to symbol. For not equal to of, you can use the same. For not equals to operation, use the same operator, either it can be integer or string, use the same operator. Okay, so next one, if you want to check string length is 0 or not. Okay, so then you can use this -z. So this will check the length is 0 or not. Okay, means, see here, you can write the expression like this: -z space capital A. So capital A is a variable, it is a string variable, it contains some string like HAI. Okay, so it has some string. So is it a zero length string variable? No, it is not zero length string variable. So this variable is having some characters, those are HAI. So the length of this string is 3. So it is not 0. So you are checking 0 or not. So it is not 0. The result is false. Okay. So next one, you can check non-zero also. String is not 0. Okay. That you can check using this -n. If it contains non-zero value, then the result is true. Now here, if you say -n space a, you are checking this a string is non-zero or not, means some characters are present or not. If character is present, then it will return the length. So here in this case, the length is 3. Okay. So n, yes, it is not 0. The result is true. The expression result is true. Okay. If you write the same thing in expression like if, so in this way we'll write if condition in case scripting. Okay. Then you can say print. Okay. So here my requirement is I want to print some string which is non-zero. Okay. If it contains some string, I want to print, otherwise I don't want to print anything. So then I can write this statement like this. Okay. Yes. So here this is the if condition. This printf will be executed when a contains some non-zero string. Okay. If it is empty string, if a is empty variable, then it will not be displayed. Okay, simple. Fine. For string comparison, you can use these operators. For others, integer, you can use these operators. Okay, only the difference is while checking the equality, if it is integer, use double equals to. If the equality is for between two string variables, then use single equals to. If it is string. Okay, fine. If you use for integer, suppose a, b are string variables, if you use double, it will not check properly. Okay, fine. So again, it will not generate any error, but it will not check properly. It will calculate some ASCII values, and based on their result, it will do the action. Okay, fine. So for string variable comparison, use single equals to. Use single equals to symbol. Okay. So these are relational operators, and operations are greater than or equals to, less than, or equals to. This one is equals to, not equal to. Okay. For string variables, single equals to symbol. This one. For integers, you can use this one. Okay. Fine. Next one, logical operators. Mathematical, relational, logical, and file. Okay. So logical expression is nothing but if an expression built using some logical operators, then we call it as logical expression. Here the logical operators are and, or, not, and, or, not. Okay, same operators as we used in the awk command. Second one, the process, I mean it will do this, the functionality is also same. Okay, in the case of AND operation, when all expression values are true, then only the result will be true. If any expression value is false in AND operation, then the entire result will be false. Okay, we have seen the truth table diagram also, right? If you remember, we have seen the truth table diagram for AND or NOT operations. Okay, so this is AND operation truth table, OR operation and NOT operation. The symbols, I mean operators are same. Okay, yeah, here I should use OR. Okay, right. So operators are same. For AND operation use ampersand, double ampersand without any spaces. For OR operation double pipe symbol without any space. This is the NOT. Okay, so in the case of AND operation, when all expressions result is true, then only the result will be true. Otherwise, if any one is false, then the entire result will be false. Okay, here we are taking only two expressions. You might be taking a number of expressions. Okay, see, you can take any number, but the result, I mean the condition is same. When all are true, then only the result will be true. If anyone fail, entire result will be false. Okay, so this is AND operation. OR means if any one is true, any one is true, then the result will be true. Any one is true, the result will be true. Okay, when all are false, then only it will fail. Okay, so this is NOT operation. So these are logical operators and logical operations in shell script. Okay, K shell script. Fine, we'll continue this file expressions in the next session. We'll continue with this file expressions. So generally file operations are like, you can check whether the file is a readable file or not. Okay, so whether the file is writable or not, whether it is executable file or not, whether it is regular file or not. We have different kinds of files, right? We discussed it in the initial sessions. Okay, so generally a readable file, writable file, executable file, regular file. Okay, otherwise if exist and it is a directory or not, whether that particular given item is a directory or file. Okay, so these kinds of operations generally we have. Okay, so that we'll discuss in the next session. Okay, we'll take some file and we'll check whether the file is readable or not. Yeah, we can do. We have some operators. Using these we can check all these file operations. Okay, right, we'll continue in the next session. Thank you.